2. Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com program, brought to you by Techstrong and Broadcom Software. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting program ahead. First, I do need to cover just a couple of housekeeping notes. Today's session is being recorded, so if you miss any of our discussion, maybe you'd like to rewatch or share with a friend. The on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, and we really hope that you do, we want you to send those in to us using the Q&A tab. You can find the Q&A tab on the right side of your screen, where you'll also find the chat tab. And that's where we want you to get to know your fellow audience members. Let us know your thoughts throughout today's program, or maybe just from where you're joining us. If you navigate to the handouts panel on the far right side of your screen, you'll see 4 resources there that our sponsor has made available for you. So please do download those and check those out at your own leisure. And of course, before we close out, we are giving away 4 $25 Amazon gift cards. So be sure to stick around for the duration of our program. So the topic of today's discussion is continuous everything. 8 continuous testing best practices to attain your continuous delivery goals. And I'm joined by Shamim Ahmed, CTO for DevOps Solutions at Broadcom Software. Shamim, thank you so much for joining us today. Would you like to take it from here?
Yeah, absolutely. Thank you, Cody. Hello, everybody, and thanks for joining me for this webinar. My name is Shamim Ahmed. I'm the CTO for our continuous delivery solutions here at Broadcom. I focus on strategic innovations for our products. I also work with many enterprise customers as a trusted advisor to help them with their DevOps journey and DevOps transformation, all the way from helping them architect and design their DevOps pipelines, all the way to implementation and cultural and technology transformations. So I have a very exciting subject for you guys today. What we will discuss is some of the key testing best practices that enable testing to be truly continuous in the context of DevOps and continuous delivery. As all of you know, we live in an age of DevOps transformations, and testing is no longer an isolated activity. So testing practices must really be tuned to support our organization's DevOps aspirations. So with that in mind, we will discuss 8 practices where we looked beyond the scope of testing alone to see how they support our DevOps goals. Now, most of these practices you'll probably recognize. They're not new, and you will be familiar or be implementing most of them. What's different is how we position these practices in the context of the DevOps lifecycle. So applied correctly, any and all of these practices will significantly help you with your DevOps efforts. So we will see what those DevOps goals are and how these practices help you meet those goals. So with that, let's get started. So we will cover briefly, some of the industry context and the challenges that sets it up for why we need this kind of a solution. Then we will talk about what is continuous everything in the context of DevOps. We will review all the best practices one by one. Again, we have a lot of content. And then we will illustrate how all of these different practices come together in the context of a very popular use case around continuous performance and reliability testing. And there's a lot of content to present here, but as Cody mentioned, we have additional resources that we have for you that you can look at offline, so you can get more details on all of these subjects. But again, feel free to submit any questions that you have, and I'll be happy to answer at the end of the presentation. Alrighty, so let's look at some of the industry context and challenges. I'm assuming all of you are familiar with the DORA report that the Google Cloud team publishes every year, right? So the latest one came out just a couple of weeks ago, and Broadcom is one of the key sponsor for this report. So I'm assuming that all of you are familiar with the top 4 metrics that the DORA group has standardized and measures organizations for baselining their maturity and capability. So these are deployment frequency, which measures how often do you deploy changes to production to end users. The lead time for change is the amount of time that goes from the time the developers commit code to production to commit code to the source code management system to the time it shows up in production. The time to restore service is the amount of time that is spent in recovering from any kind of failures in production. And the change failure rate refers to what percentage of your deployments cause things to break in production. For example, outage or a service degradation that requires some kind of an action like a hotfix or a rollback or a fix forward and a patch. Now, what you see highlighted here are the change failure rate metrics. So you can see here for low maturity customers, the change failure rate is alarmingly high. It's 46 to 60%. Last year, for those of you that are familiar with the DORA reports and follow the reports, that number was 16 to 30%. So this means that low maturity customers, while they're trying to go for velocity, they're suffering on quality, right? It's so obviously every customer that I talk to says, we want higher and higher velocity, right? But it's very difficult in that process to also manage the quality expectations. And we can clearly see that low maturity customers are struggling there. Even medium maturity customers have a fairly high, change failure rate. So 16% or higher change failure rate in my mind is significantly high. So 80, as it turns out, if you look at the DORA report in detail, 88% of all enterprises fall into the low and medium category, and they have change failure rate higher than 16%. Now, there are some enterprises that we've talked to that have relatively low change failure rate or CFR. I'm going to be using the acronym CFR. Um, but then when you talk to them, they have a very, very high change review and approval cycle time. So, for example, we were talking to a financial services customer, and they told me that for every single change that they make to production, even if it's one line of code change, they have to spend up to 3 days, or at least with at least 7 or 8 different personas to review all those changes before they can go to production. Which means that adds to cycle time. So even if they have managed to keep the change failure rate, the cycle time or the lead time for change goes up, right? Now, in my mind, that represents a significant problem, right? I know every enterprise wants to go for velocity, but velocity without quality, in my mind, is wasted effort. As a matter of fact, the DORA report makes a mention of that. They say that high software delivery performance is beneficial, obviously only when the operational performance is high. So delivering at breakneck speed doesn't really help if you don't meet the user's reliability and quality and customer experience needs, right? So that is in fact the big challenge that we are struggling with, and the DORA metrics clearly tells us that there is a challenge there. So as customers try to accelerate, they face significant challenges from a QA and a testing perspective, right? And we've done multiple surveys after surveys have indicated that in the whole DevOps process, testing in QA is a huge bottleneck, right? So this survey, one of these surveys tell us that 63% of our customers perceive that testing as a QA is a big bottleneck. And then as much as 25% of the productivity is lost. And this comes from a very recent software testing pulse meter report, right? Now, in response to this, obviously we've been advocating for what we call continuous testing, right? So testing has clearly evolved from what it was in maybe 10 years ago, where it was a siloed activity happening at a particular point in time, right, to more of a continuous testing mechanism where testing is embedded throughout the SDLC. And we've been talking about this for at least the last 10 years now. But the question is this sufficient, right? Is embedding testing in every part of the life cycle, or even automation of testing at every part of the life cycle, is that sufficient? And the answer seems to be no, because we've talked to customers, we continue to see the following types of challenges, right? So, for example, we see a lot of waste. And that's because most of our customers that we talk to don't have optimized the test. They have either over testing or under testing. So when you're over testing, you have waste, and if you're under testing, you have risk that you're not addressing, right? So gaps in the test coverage. We often see that the test pyramid is not very optimized. People have inverted test pyramids or the ice cream cone, and we see very little insight from production in our testing today, right? So we'll talk about that as part of our shift right. We have high CFR. We still see that, right? And what we see here is a disconnect between testing the activity and quality of the outcome. Remember, quality is the outcome and testing is only the activity. So having testing doesn't necessarily mean that your outcomes are guaranteed unless you tweak the testing to make sure the outcomes can be addressed. So we need to know what the outcomes are and how we continuously track to the outcome, and not just be bound by the testing metrics themselves. One of the key things that we've seen from our customers is there's no easy way to predict the risk of a change before go live, right? We've seen many of our customers do what we call release and pray, right? So they do the best case and they release go live and they pray that nothing breaks, right? And I'm sure that many of you can to relate to that challenge because this is a very difficult thing to do because there are so many data points that you have to collect to do risk prediction for changes that are going to production. We already talked about the high change approval overheads, right? So for customers that are highly regulated and cannot afford high CFRs, have to spend a lot of time and energy um, in approving the changes or managing change. The change approval process is very, very cumbersome. And we know from the DevOps best practices that high change approval overheads are not worth it. So we have to come up with a different mechanism that allows us to go live, but yet be predictive about how risky those changes are and control those risks. We're all familiar with the test environment hell, right? So as we do more and more DevOps, as we do more and more pipeline-based systems, we now have multiple pipelines of code running around, right? Particularly if you're doing microservices and distributed and cloud architecture, sometimes even hundreds of pipelines where you have to manage your test environments, right? So for most of our customers, from the beyond the testing to the production, there are at least maybe 3 or 4 different kinds of test environments, right? You've got the integration environment, the system environment, system testing environment, pre-production environment, right? So at least 3, maybe 4. Some customers have as many as 12, right? Now with all of those environments out there, and it means that you have to manage those environments correctly, right? In other words, as your application build moves from one environment to the other along the pipeline, you have to make sure that you move also the right test assets there, right? Just being able to provision the environment fast using a cloud environment doesn't necessarily mean that you've got a good test environment because you have to populate that environment with all the right assets, right, that go along with the application build. For example, you got to have the right test scripts, you got to have the right test data, the virtual services, the test configurations, and that is a big challenge to manage when you've got hundreds of pipelines, and it becomes a very difficult thing to manage, particularly in our current deployment environments, which is multi-cloud, hybrid cloud type of environments. We've got at least 3 or 4 different cloud environments to manage across, many applications with hundreds of pipelines. And last but not the least, which is related to the test environment, is that test asset management is a nightmare to manage, right? Because we talked about not just the test scripts or the tests, but also all of the assets that go along with supporting the test, like the virtual services, the test data, the test configurations, et cetera, et cetera. In the face of rapid change that we face in Agile, managing those assets is also a nightmare because you have to continuously refresh those assets across all of those different pipeline environments, right? So you have to sync the changes that are happening in the application to all the test assets, across all those pipelines. And many customers have told us they have significant personal identifiable information or PIA exposure issues, particularly in the context of test data. Many customers are subsetting the test data from production to support the test environments, and they fail to mask or desensitizes the data, and many breaches happen from intentional or unintentional access to the PII data and pre-production environments, right? So again, these are some of the big challenges we see. There are other challenges too, but net is, we know there's a challenge around balancing velocity with quality, and specifically we know that from a quality perspective, there are many other challenges that we talked about here, some of which we just mentioned here. So with that in mind, let's look at what solutions we can bring to the picture to solve this problem. Okay, and that's what we are calling continuous everything. So we live in a world of continuous delivery. As you know, continuous delivery requires everything to be continuous, which means that in testing, everything that we have should also be continuous, right? So our whole goal here is to show you how our testing practices need to evolve to support the specific goals that have been laid out in the DORA metrics, right? So it's a completely different approach, around how we apply the practices we all know and love, but from a slightly different perspective. So let's look at what a life cycle is, right? And I'm going to be showing you this life cycle over and over again, because this is typically what a pipeline looks like from a CI/CD perspective, right? You got all the different processes going from the backlog all the way to production. Now, if you think about the key metrics that we saw from Dora, right? The lead time for change is the time that goes from the commit to the time the software shows up in production, right? The change failure rate is obviously the failures that happen when we go from pre-production to production, and of course, the mean time to restore is the time it takes to recover, right? The two big drivers amongst those four metrics are LTC and CFR. Okay, now many customers have told me, hey, we don't have to worry about quality because we have our mean time to restore is so fast that even if things fail, we can quickly recover before anybody notices. That may be true, and I think that's good to have mean time to restore. But think about what it does, right? The whole idea behind fast software delivery is to get the software out to your users so that they can use it and generate value. If your system keeps failing, right, at the rate of 46 to 60%, and all you're doing is simply recovering from failure before anybody has noticed, that means that your users are not actually getting to use your system, right? So that doesn't represent value, right? That may be a great technical capability to have. I can go at breakneck speed, I can recover at breakneck speed, but hey, my users are not getting to use my software because I'm so busy pushing things to production and then breaking and rolling it back, right? So in my mind, that's waste, right? Even though it's a great technical capability to have. So that in my mind is a big distinction between a capability and an outcome, right? At the end of the day, we're looking for an outcome which is value based, right? That's the reason why we build this capability. So what we need is in order to be able to support the minimization of lead time, we need to shift left most of our quality injection activities, right? So I'm a big believer that quality has to be injected and not tested out, right? Testing can only help you so much. So we have to inject quality based on our quality goals in the CI part of the life cycle. This is really where the creative work happens, right? And in the CD part of the life cycle, this is where we need to focus on impedance reduction, because everything that we do here that's an overhead slows us down, right? I have seen, for example, many customers will tell me, you know what, I've got excellent test automation. I'm doing 100% test automation. Great. Okay. But they're saying that all the test automation happens here. In other words, they're building the test automation in the CD part of the life cycle. So in other words, the application build that they're pushing out cannot be tested until all the automation is complete, right? So while they've got a get test automation program, it's actually slowing them down because they're not doing the automation at the right time in the right part of the life cycle, right? So even if they've got a local optimization, they're not getting what we call global optimization. So that's one of the key things we're going to be looking for in our best practices is how do we get out of the mindset of local optimization where I'm doing a testing process or optimizing it very much to looking at the big picture and trying to achieve the global optimization where I'm trying to minimize the lead time and at the same time trying to keep the CFR as low as possible. So the two concepts that we need to bring this to life are what we call continuous quality and continuous flow. So continuous quality is really a mindset where we embed quality in every stage of the life cycle, right? We talked about embedding testing at every stage of the life cycle, but now we're saying we need to keep in mind what is the outcome and make sure that we're testing for that particular outcome, whatever the goal may be. It could be reliability, it could be customer experience, it could be usability, whatever the quality outcome is. We need to make sure the tests are focused based on the quality goal. And the second one is the notion of continuous flow. So continuous flow is the concept from lean methodology, right? That includes more than just velocity, right? It also includes the minimization of impedance and waste. So for example, we just talked about mean time to restore. It's a great technical practice from velocity perspective, but it also creates waste, right? So we want to be able to not just create velocity, but also minimize the waste, because at the end of the day, we need to generate value from work, and waste reduces value. Okay, so with that in mind, let's go through each of these practices. Um, so for our testing to be continuous, truly continuous, every testing sub-process that you can think of and every tool that you use must also operate in a continuous manner. In other words, they must support these two concepts of continuous flow and continuous quality. Okay, and that's why we call it continuous everything. And and even though I will just look at only one testing process today, we call continuous performance testing. You can think of any testing process that you are implementing today, and you need to apply this check. Am I implementing continuous flow and continuous quality, right? If you're not, then you probably have room for improvement. Okay, so I'm going to go through those 8 practices, and I'm going to show you how each of those practices support continuous flow and continuous quality. I picked red for continuous flow because I found out that in the spectrum of light, the red color travels the fastest through any kind of medium, right? Let's say for example, through a prism, right? Compared to the other frequencies, and of course, quality is green. And I'm also going to show you these 2 legends, right? The driver means that particular practice is a big driver for that particular thing, or it supports that the one of the 2. Okay, so with that, let me introduce the 8 practices. Again, all of these are things that you probably have seen before. So I'm not going to go through each one of these things on this slide, but let me walk you through each one of these things, and I'll show you how they apply in the context of the flow and the quality in the context of the CI/CD lifecycle. Again, I believe that most of you are going to be familiar with of these things like shift left and shift right, automation, test pyramid. But let's walk through each one of these things. Okay. So number 1 is progressive build out. So progressive build out means that we build out the continuous testing artifacts progressively along the life cycle, at least one step before when the assets are really needed, right? There is no point building out all the assets at a time, when nobody's using them, because they'll sit idle, right? And each step of the life cycle enhances the artifacts that were built from the previous step, right? So I will show you in the context, for example, of test data management, right? So as you can see here, the design supports the development agile parallel development phase. The agile parallel testing supports all of the needs for the test for the CD process, et cetera, et cetera. But let's look at it concretely from a perspective of a very common problem in testing, which is test data management, right? As you know, test data management is a big problem for most of our customers because it's very difficult and tedious to collect and provision test data. So let's look at how we would do test data management as a process using the progressive build out, right? So for example, we'd start with capturing the acceptance criteria in the backlog phase. And in the design phase, we would design the test data model and the test data generation rules. And at this point, we generate the synthetic test data that is required for testing during the development phase, right? Because developers don't care about extensive test data, right? They care about lightweight test data, and that's easy to do using the synthetic test data principles, right? So we will create the synthetic test data in the design phase so the developers are not starved for unit testing and component testing. And one of the key reasons why developers tell us they don't do proper unit testing and component testing is because it's just too cumbersome to set up the test environment and the test data, right? So we do the synthetic test data generation in the design phase so that developers have it ready, when they need to run their test. Similarly, during the development, we have the agile parallel test phase where we enhance and update the test data that we created, the synthetic data, with additional rules, and also do maybe subsetting of data from production and mask the data so that we can support the more extensive tests that you need to run in the CD process. The key point here is that we're reusing something that we already created, enhancing it, and making it ready before anything starts in the CD process, so that when it comes time to do integration tests or systems tests, all the data is ready. If I have a highly optimized test data process where I'm creating the test data here, we're creating waste because you're simply going to slow down the lead time for change. Okay. Now that's a very, very important concept we talked about is the assets must be created at least one step before they're actually used. Okay. Similarly, when we do this, test data hybridization, we can use it for our regression test and build verification test, and of course for all of the other test phases that are necessary. Now, as part of continuous deployment, we also have to, or continuous delivery, also have to make sure that we package all this test data that we created for the right environments. For example, a test data that is going to be used here is going to be different for test data in the system test, and so on and so forth, right? So just like we talked about, we're going to package the right test for the right environment, we also have to package the right data for the right environment, right? So all of that packaging needs to happen here as well, so that it can be included as part of a deployment engine and orchestration engine, so that it knows how to provision the right data in the right place for the right tests. Okay, now on the right side of the equation, the other thing is, remember, we are progressive, right? So which means that as we go from left to right, our test assets become progressively more mature, right? We start out with very simple synthetic data, but as we go to more and more tests that are, for example, pre-production tests, which resemble UAT tests or end-to-end tests, our test data is also much more realistic and represent more production-like test data that is obtained from masking in production. So you can see here a notion of progressive build-out of the right test assets at the right time, as an example using test data management. And of course, we also use our monitoring in production to make sure that when there are significant data changes, we can refresh our test data by subsetting from production as well. So hopefully that gives you a sense of how we do progressive build out as an example for the test data management, right? We start out small, start out lightweight, support the developers, and then progressively become more realistic as we go from left to right by enhancing the test assets that we built. So we can clearly see here that this is a big driver for reducing idle time, right? Because we're killing off any kind of idle time or wait time, and of course we support the better quality through by enabling much more thorough testing, particularly from a development perspective, right? This is where we want to focus our testing efforts as part of Shift Left, right? We're supporting the developers with whatever test data needs that they have by synthetic generation early in the life cycle and making it easy for us. Okay, all right. So let's move on to the next slide, which is around. But before I move on, one of the key assets we published is my blog on test data management. Again, there's a lot of content I talked about here, but please look up that blog on continuous test data management that is on the list of your resources that describes the whole process in detail around how we address this challenge of continuous test data management using these progressive build out and all the other principles that we're going to talk about in just a minute. Okay, next one, shift left. Now, this is something that I'm assuming all of you are familiar with, and this is probably one of the most influential quality injection disciplines, right? But at the same time, shift left also ensures that the testing artifacts are built out in the CI part of the life cycle so that there is minimal impedance in the CD part of the life cycle. So that means that all the creative work needs to happen here, right? Which is in the CI part of the life cycle. And you guys are all familiar with the key shift left practices, things like early requirements validation, doing test-driven development or behavior-driven development. At the same time, we want to make sure that we do the test pipeline design so that we know how to associate all our test assets with the pipeline mechanism, right? Same, we talked also about progressive automation, for example, doing the automation of the new functionality right here so that we're not starved for doing automated testing in this part of the life cycle. Okay, so so again, shift left is all about not just moving the work to the left, but also making sure that we are very sensitive to what our quality goals are, because that's really where quality injection happens, right? We much rather make sure that we have a highly solid development process where we can catch and fix defects early in the process based on the right kind of tests that are designed meant for the quality goal that we're shooting for. And when we talk about the continuous performance testing, I'll show you what the quality goals are from a performance and reliability perspective and how we can write tests specifically to that goal, right? But the whole goal here is to maximize our testing here at the unit, the component testing levels, right? Some of the key principles. Number one is requirements testing, right? So we talk about requirements as being the driver for quality, right? And if you don't test our requirements early, then chances are that we will not get the right outcomes that we're looking for. So we call this requirements validation. There are various ways to do good requirements validation. One of the ways that I'll talk about just shortly is using model-based testing. The other is using real customer feedback in terms of our understanding of the requirements that they're looking for, as well as using data from production to validate, if you're building the right things, right? Because building the right thing is just as important as building it right. Number two is practicing, test-driven development and behavior-driven development. These are fairly mature principles now. For those of you that are not familiar with this thing, the whole idea is to understand the requirements well enough to be able to write the tests, acceptance tests, or even unit tests before the code is actually written, which means that again we're shifting left, right? The tests are ready, so as soon as the developer has built out the code, they can incrementally test their changes without having to wait. Focusing on code and API quality. In other words, the focus is clearly shifting left on the things that are being created, right? If the code is broken, if the quality of the code is wrong, it won't scale, right? So I think this is one of those things that they talk about, right? You can't scale crappy code, right? So focus on the quality at the component level, at the code level, or at the API level, for example, that represent the boundary of a component. Um, Focus on unit testing, not just from a functional perspective. We see many of our enterprises just focus on functional testing at the unit level, but ignore other non-functional testing like performance and security and reliability testing, right? It's just as important to build in all of that quality component into the component at the unit level itself. Otherwise, you're going to simply leak those defects to the right part of the life cycle. It's very, very important, as we talked about in the context of continuous delivery, to build a robust pipeline, right? And to do the pipeline testing right up front, right? We rarely talk about pipeline testing. We don't need to focus on shift left, and that means application testing. But you will see that many of our customers suffer from poor quality because of pipeline issues, right? The pipeline itself is broken, right? And how can you assure the quality of an application if your pipeline itself is broken? So it's very, very important to, when you design your pipeline, to test the pipeline right up front to make sure that the pipeline is stable and the pipeline can scale as you throw more and more payload onto it. And that's what we call pipeline and configuration testing. So for many of you that are using principles like infrastructure as code, that makes it easy because infrastructure is represented as just as any other code. And if you change that infrastructure code, then you can test it, right? Using tools like Puppet and Chef, Ansible, and so on and so forth. Service virtualization is a key capability to enable shift left. So service virtualization is a technology that allows you to simulate an application dependency. So for example, in an age of component-based architectures, you've got a component that depends on other components, and you can't build and test your component if you've got all these dependencies on other things, because those other components may not be available or may not be ready, right? So service virtualization helps you create emulators for those other dependencies so that you can freely test your component or the application or component or change without having to be bogged down by the availability of the dependent components, right? So it's a key best practice that you need to implement. We already talked about test data. Again, the key thing here is to have a progressive approach to test data, so you can do a combination of synthetic and hybrid approaches that allow you to do very lightweight synthetic data generation in the early part of the life cycle, and then and become more hybridized as you go to the right side of the life cycle. And last but not the least, don't forget your people skills, right? So we advocate investing in a new breed of testers that we call SDETs, software development engineers and tests. So these are essentially software engineers who can do testing. So they bring a white box approach to testing as opposed to the black box approach. So in the CI part of the lifecycle, the continuous integration part of the lifecycle, you truly need support for white box testing to support the developers, as opposed to the black box testing that you need in the CD part of the lifecycle. So again, these are some of the key things. There may be other components, but these are the ones that we feel are absolutely key to supporting the shift left initiative. Okay, shift right. So shift right is obviously about making sure that testing continues in post-production environments, right? And there are many examples. For example, customers do crowd testing. They do chaos testing to test for resiliency by injecting failures, doing canary release and AB deployments to make sure if they're introducing a new feature, if that is acceptable to new customers or not. But one of the things I like to point out is rollback testing, right? So we talked about fast recovery from failures, right? So many times the best way to recover is to do a rollback. And how can you make sure that you can do a rollback in production if you don't do rollback testing? So it's very, very important that for every deployment and every pre-production environment, you also do rollback testing for every deployment, right? You're going to build that as part of your testing practice, so that you can know for sure that if I'm putting something to production, I can easily roll it back without breaking something else. By the way, it's not all that simple, particularly if you have data changes, right? So it's a very complex process if you've got application changes coupled with data changes as well, because data rollback is a little bit of a difficult problem to solve, but it's possible. It's possible to automate. It's possible to test for it. But for me, the most important thing about shift right is not actually doing the testing in production, but generating insights from the production environment. As you know, the production environment is extremely rich, and in most cases, testers typically don't have access to the kind of production data that we would like, right? And part of the problem that we're trying to solve with the shift right is how can we make that much more easily, readily available to our testers so that you can glean insights from production. For example, in production, you know, our real users are using our product, so we know, what, for example, what they like, what they don't like, you know, what use cases are they using, what are they adopting, et cetera, et cetera, et cetera, right? So if you could glean some of that information, it'd be great. There are tools that are available nowadays, guys. I mean, luckily, you know, that help us actually look at all of the production transactions that the real users are conducting and generate tests from them, right? Or even do validation of requirements, right? Based on what you know, what the users are telling us, right? So this is actually helping to close the loop by generating insights from production environments. Of course, we already talked about doing subsetting of data from production environments. We can even generate virtual services by recording our services from production, so that we get a very realistic emulator that we can use in our CD environments, right? Also, too, understanding of the failure causes is very important, and we'll talk about this one in one of the key practices we talked about in just a minute. Is how do we can understand failure causes and then use that for failure prediction? Okay, so again, clearly this is a big driver for quality because it helps us focus on real user experience and supports you know, your velocity by automating the flow of insights from production to the backlog. All right, moving into the next one, which is the automation of toil in the CI/CD process. Now, this is fairly obvious, right? So we talked about how do we reduce the lead time for change, and one of the key ways of doing that is to make sure that, you know, all the repetitive processes that we have around deployment of assets as you go from left to right is completely automated. There's no reason to have manual deployments, right? For your build assets, for your test assets, et cetera, et cetera. You know, we live in an age of automation. There are plenty of tools that are available for us to automate this thing. So this should be something we absolutely focus on and make sure that, you know, these, that we are able to implement all of our automation laws using API-based integration. So in other words, there's no handoffs, there is no human interaction as we go from one step to the other, right? And this has a very, very big impact on cycle time, right? And again, remember, like we talked about, don't forget your automated rollback testing. If you can automate deployments, you should be able to also automate your rollback testing, and that's very, very important for supporting your mean time to recover. Okay. Already, alignment with the test pyramid. We all have heard about the test pyramid and how we need to be doing more and more testing at the bottom part of the life cycle and less because, you know, as you know, these kind of tests happen in the CI part of the life cycle, and these tests are in the CD part of the life cycle. They're much more time consuming and they're cumbersome to execute, right? So that's one of the key ways that we actually support this whole notion of reducing the lead time for change. Now, there are various ways to do this. You know, in our opinion, one of the best ways to do this is to do what we call model-based testing. So, as you know, we have requirements and tests at different levels of the taxonomy, right? Or granularity. So we have stories that are more focused on the dev and the component. There are features that are more from a cross story or feature perspective, and so on and so forth, right? So so one of the best ways to do this is to create what we call you know, models. And a model is really a visual diagram that captures the behavioral flow of the application, or what we call behavioral modeling. We talked about, you know, behavior-driven development, or BDD. Essentially, this is visual behavior-driven development, where we capture the behavior of the application in the form of a Visio type diagram. There are many tools that support this. One of them is Broadcom's Agile Requirements Designer. But once you you know, create this model that describes the behavior of the application, you can generate all the test assets that you want from it. That includes all of the test automation assets and also the other assets like, you know, test data and virtual services. Now, the beauty of this is once you use a model-based testing technique, you can use very sophisticated algorithms for generating tests with very precise optimization. Now, what you can say is, you know, generate the tests at the lower levels with the lower level of optimization. In other words, you do much more thorough testing and generate tests for these levels and with a higher level of optimization, which means that you have less tests to deal with, right? That's one of the most precise way of generating, you know, tests that have a measured but a predictable level of coverage as you go up and down the hierarchy, right? So you can control exactly what level of optimization that you want, and typically we recommend, you know, very high levels of optimizations up here and lower levels of optimizations here, which means that you're doing more thorough testing at the bottom part of the pyramid and less thorough testing at the top of the pyramid. The other thing that you'll see here is this thing notion around change impact testing, right? That again, we talked about change failure rate, right? So it's very important for us to test for change impact. So that's the next practice that we want to talk about. It's very important for us to understand what the change is, and focus our testing on what has changed, right? And that is the key best practice in my mind around how we enable velocity with quality. I've seen many customers have extensive regression test packs, for example, hundreds and thousands of tests, and for every change they will rerun all the tests. And I ask them, right, why? And they tell me, well, it's very hard for us to understand what is the impact of the specific change, and how do we tweak our test suite specific to those changes, right? So the whole goal here is to help you understand how you can tweak your testing so that it's very specific to the changes that you're making, right? There are various ways to do this, and the idea is to make sure that you analyze the impact of change and understand what the impacted test sets are in the design phase, so that you only run those, in your testing environments, particularly in this phase, right? This is where you need to be really careful about running the fewest number of tests that give you the highest bang, right? So that's really the whole idea. So there are various ways to do this. Let me walk you through a couple of ways. The first one is what we call the inside out code change, right? So this is saying that I'm going to look at what code has changed and understand what is the impact of the code change on my unit and component test. So this is typically most applicable for the CI part of the lifecycle for white box tests. So there are tools that are available now that can do a mapping between the code that you have and the test that you run for every test run, and will do an analysis of your code changes and then tell you what tests have been impacted by the specific code change, right? So for example, Broadcom has a tool called Test Advisor. Microsoft Azure has a test that does this kind of thing. But there are other commercial and open source tools that are available nowadays that will help you understand the code changes that you're making, that your developers are sending to your source code management system, and tell you what specific test cases that have been impacted, particularly at the unit or the component level, that you can focus on for running. And then there's the outside in. So this is mostly applicable for your system integration tests and integration tests, right? So this happens when a requirement changes, right? So this is the outside in view. And again, the best way to enable this is through model-based testing, because when you change a model, the model tells you very precisely, you know what, here are the test cases that have been impacted, here are the new test cases that need to run, and more importantly, here are the deprecated set of test cases that are no longer necessary, right? How many times do we run into situations where our test suites keep growing and growing and growing and never decreases because we're all afraid to take test cases out, right? So we have to try to keep not only our testing lean, but also do it very focused on the changes that we're making. And model-based testing is one of the easiest ways to understand the impact of the change, and running only the tests or focusing the tests that are most impacted by the change, either in a requirement or in a code. Okay. Now I know I'm throwing a lot of theory at you guys here, but believe me, there are technologies and processes available to address these new processes. Okay. The seventh one, rapid feedback and insight. Now, I cannot underestimate how important feedback is. So developers, the best way to inject quality and help developers is to give them as fast feedback as possible. And I put out some times here, right? For example, for unit test, the feedback time should be the order of seconds, per test. For build verification tests, for regression tests, should not be more than 5 minutes. You know why it's important to provide fast feedback? Because otherwise the developer will move on to something else. They have to do a context switch, right? Delayed feedback is delayed quality, right? The faster feedback you can provide, the better it is. Similarly, from integration test, shouldn't take more than 10 minutes, right? Use the principles of change impact testing, the test optimizations so that you can optimize your test as much as possible here, not only to reduce the lead time for change, but also to reduce the feedback time, right? And try to aggressively optimize your post-build test, right? And try to give. So there are a couple of different things that we can do to provide rapid feedback in addition to the feedback from the testing cycle, right? And here are some of the key things that I like to talk about from a perspective of insight. We have so much data that is available to us from a pre-production and post-production phase, right? So we talked about data, for example, from from our build tools, from our source code management tools, from our deployment tools, right? All the data is generally what we call dark data. We as testers typically don't exploit the data and provide and use it to provide automated insights. So let's look at how we can do some of those things, right? Wouldn't it be ideal if I could, for every stage of the life cycle, for every change that developers are making, I could provide some kind of a score that says, you know what, for this change that you just introduced, for every change or commit, here's the risk score for that change, right? Or after every build, here's the risk score for that build, and similarly, so on and so forth, right? As we go from left to right, if I could use all the data that I'm collecting, if I can provide some kind of a risk score back to them in near real time that would tell the developer, here is the score and here are the reasons why the risk is such and such, that I can quickly go back and address that problem, right? Wouldn't it be ideal if I can do that? And the answer is that yes, it would be, and there are tools that are available today that help you do that, right? One of the tools, and by the way, there's a blog that I've got that we call continuous observability. Observability is a principle of continuously collecting and analyzing data and providing insights from the data, right? And typically, observability is a discipline that is we've implemented in production environments, right? For example, in our AI ops technologies. But I'm making a case for shifting observability to the left, so we can actually analyze pre-production data and generate insights for our testers and developers. So please read this blog. There's a lot of detailed practices that I put out there that talks about how to implement continuous observability, and there are tools that are out there as well. So obviously, observability is great for driving both velocity and quality. Why? Because it provides instant feedback on failure risks, right? The whole idea is to control our failure risk, and then allows early remediation from a quality perspective. If you can tell a developer right when they change the code, that here's all the risk factors, right? Here is why you need to go fix them, and they can go fix it right away, even before the tester has a chance to do any testing, right? That's awesome for driving or injection of quality. So there are various ways to do this. One is to use, for example, heuristics, right? So heuristics, for example, we know, for example, things like, for example, if you've got high code complexity, or if you have high release complexity, chances are your release is going to be riskier or change is going to be riskier, right? So we know these things from heuristics, right? And we build rules to look at, for example, every change or every release or every deployment, and apply those rules to come up with some kind of a score, right? And provide the feedback to our developers and testers, right? So for example, one of the things that we frequently see is flaky tests, right? These are unstable tests that produce indeterminable results. So the earlier we identify this flaky test and tell our developers and testers, hey, we've got some tests that are demonstrating flaky behavior, you can go and fix it. Similarly, coverage is oftentimes a big indicator of how good or bad your things are. So this is again a heuristic-based approach that is supported by tools that we have in Broadcom that provide this kind of a score for every phase of your life cycle as you execute your continuous delivery, right? The more exciting tools that I'm looking at, that we're building out, is using AI and ML. As I said, there's a lot of data in our pre-production environments that we're not exploiting, and more importantly, we're not correlating the data with our post-production data, right? So what we are doing is trying to see if I can look at all my failure events that have happened in the past, right? So for example, let's say in the last 5 or 6 months, I've had X number of SEV1, SEV2 defects, right? High severity defects in production. Now, if I can take those data and correlate it with all the pre-production data for those releases that have happened in the past, and create a machine learning model based on that data, and then apply that machine learning model to my current release, right? By looking at all the data, that is all the changes that are happening right now, I can actually generate real-time feedback on the quality of the current release relative to the failure risk, right? Believe me, guys, this is possible. The technology is advanced. We're building a solution within Broadcom to do this kind of thing. So let me show you an example. So just for purposes of illustration, I used Google Analytics, the machine learning thing that Google provides. I downloaded all the failure data for Eclipse. For many of you may know, Eclipse it's an open source IDE. So if you look at the Eclipse GitLab repository, they have published all their failure data for the last several years, and along with that, all of the source code management data, all the pre-production data, right? So I did some machine learning, and there's a algorithm called gradient boosted trees. So if you look at the Eclipse data set, they have about 14 defects that they slip for release, right? And by using machine learning, I was able to figure out what are the main causes for all those defects. And you can see here some of the main things are, for example, things like the code churn, right? The number of authors that have touched it. Obviously, it's an open source system, so you would expect the more people that have touched the code, chances are the more defects are going to inject, right? But code churn clearly appears to be a big thing. The number of lines added is a big thing. So anyway, the machine learning algorithm takes care of understanding what the different factors are, right? And it gives me a model that now I can use to apply for my next release, right? So for example, if in my next change, right, I see, for example, let's say the number of, let's say the code churn, and on the average, the code churn is about 4 lines of code. What if the code churn for my current change was about 7 lines of code, right? The system predicts to me right away that the number of defects are likely to jump from 14 to 35, right? So I can now use systems like this based on whatever is going on in my current release to predict high failure probability, right? Regardless of what these factors are, right? In this case, the factors are code churn, number of authors, et cetera, et cetera. For your application, maybe something different, like code coverage or leaky components, whatever it is. But the whole idea is to use machine learning to understand what the failure patterns are from past failures, and then apply it to your current release so that we can understand what the failure risk is, and more importantly, understand the factors and give them back to developers so that they can start to address these problems as quickly as possible. And last but not the least, guys, I know I have to run. We've got a few minutes left. Is orchestration of all of these processes using CI/CD platforms. Again, we live in an age where everything is orchestrated, and there is no reason why we should be running all these processes manually, right? Again, there are so many different processes, particularly across multiple pipelines, across multiple cloud environments, that it is no longer possible to do all of these things manually. And the other thing that I talked about is the more you orchestrate, the more you're able to collect data from all these different processes and tools, right? If you look at a CI/CD lifecycle, every application team is likely to have at least 10 different tools that they engage, right? From your IDs to source code management systems, build systems, your testing systems, et cetera, et cetera. Collecting data from all those tools manually is extremely difficult, right? So the more you orchestrate, the more you can collect data from these processes, and the more you can support the AI ML type activities that we just talked about, right? So again, the whole idea is to automate your processes and orchestrate them. All right, so now let's look at how we pull all those different practices together in the context of a classic problem around performance testing, right? So we all know that load testing introduces the bottleneck in the CD process, right? So many of our customers do their classic load testing before they go live, right? And which means they're going to run this long duration test and with hundreds and thousands of virtual users, and this is a big bottleneck. I have had customer after customer tell me, how can I get rid of this bottleneck? How can I get rid of my load testing so that I don't have to slow down my release, because this is really slowing me down. I need to be performance ready all the time, right? Not just before Black Friday. Okay, so here's how we can take all of the different principles we talked about and apply it to continuous performance testing. So let's quickly walk through that. So from a performance perspective, reliability perspective, for most of you guys are familiar, here are some of the key metrics we take care of, right? Availability, performance, latency, errors. So these are not new, but these are things that we're seeing more and more in reliability engineering that are practiced by site reliability engineers, right? So they use these concepts like service level objectives to set goals for these metrics and measure them and track them, right? So the whole idea is that we can now take advantage of those SLOs or even SLAs, for example, that are defined around those metrics to shift left all of our testing around these metrics, right? To see how well we are doing. Remember, these are the outcome metrics. These are not testing metrics. Remember, we focus on outcomes and quality. So these are quality metrics that we're going to focus on in this life cycle. So let's look at it, right? So we start by shifting left, right? Remember, we talked about most of the performance testing needs to happen to the CI part of the life cycle, right? So we start with the understanding of what our goals are, right? Be they SLOs or SLAs, whatever the goals are. And let's say, for example, we're trying to do testing of component of A, right, which has a whole bunch of dependencies in a microservices architecture. We're trying to validate the component A, because why? If it doesn't scale at the component level, guys, it will not scale at the overall level, right? So focus on component-based testing, and I'll show you how to minimize the end-to-end testing. Okay, so So in the design phase, we do the change impact analysis of whatever changes are going on. We understand what are the impacts on the other components, right? And we virtualize the dependencies. For example, if A has a dependency on D, we virtualize the dependency so that we are no longer constrained by the availability of D. Not only that, we can also build into this virtual service the behavior of D in terms of performance, right? So I can build in the response time, the latency of D in the virtual service itself, right? Without having to spin up a performance testing environment for D, right? The key thing here is to do performance profiling and the unit test, using synthetic virtual services for service level A, right? So I can build out a set of unit tests and I can see the trend lines for build after build and provide feedback to the developers in terms of if the build is not going right. Doing a single component regression test, this is used for validating the SLOs at the component level, right? So if I have a latency requirement or uptime requirement for service A, I can easily validate that by doing a very small duration, maybe even 5 minutes, right? Load test at the service component level that can run quickly, and I can tell if my component is going to meet my requirements or not, right? By using the components of auto scaling that is typically available for microservices architectures. Now that's all I need. I mean, I should be able to tell if that component survives this change right here and then within the CI process. If it has passed that, then I can start to look at my CD process, and then I can run, a single component scale test that runs in maybe 10 minutes by using maybe 20% of my total production load. That's enough. I mean, to be able to validate if my component is going to scale. Why? Because we're going to do auto scaling in production, right? And that we're going to do for every deployment. And then for periodically, right, we can do cross transaction tests if, for example, we feel that a particular change has impacted other transactions, but we can only do it periodically based on change impact. In other words, I'm reducing my change impact load here, and then my end use loader test that used to be the big bottleneck, I'm going to do sparingly. Matter of fact, I'm probably never going to do it, because if I'm able to validate a component or change components individually and run some scale component test, I'm more than certain that I can meet the reliability goals of my entire application, right? And I run these things only sparingly. Okay, and of course, I can do a canary test to make sure that the system behaves correctly in production, and I can inject chaos into my system, but also do continuous monitoring to complete the loop and understand my real user feedback and performance in production. Okay. So hopefully that sums it up all up. So you can tell here how I bring all these things together from a continuous testing perspective. That, again, they have a blog out there that describes this process in great detail. So hopefully that gives you some idea of how this thing gets done. So one more thing, and I'm going to conclude. So so we talked about the reliability engineering and how site reliability engineers use this concept of SLOs to set service level goals. And they also have this concept of an error budget. An error budget is the difference between one minus the SLO, right? Which is the difference between the ideal versus what is the realistic goal, right? So for example, if I have a 3 nines availability, for let's say for my next 30 days, my downtime is allowable downtime is only 43 minutes, right? So that's what we call the error budget, right? So testers can actually now start to exploit the error budget to balance velocity with quality. So traditionally, what SREs do is, if they have high error budget left for that release period, then they focus on velocity. But as they consume their error budget, they throttle the velocity and focus more on rollbacks and remediation engineering and test debt management, right? So now I think testers can take advantage of the fact and watch out for the error budget and say, hey, if my error budget is a high, then I can do more and more development and do more and more development and do less level of testing. Whereas when we consume their budget, we do more and more testing and hardening, right? So that gives us an approach to do balance of both using by better collaboration with SREs. So again, I have a webinar on this thing that talks about how we do this, and I'm going to bring it to a close here. I know we're right at the top of the hour, maybe a couple of minutes left, Cody, to see if there's any questions that I can answer.
Sure. So we did receive 2 questions. This first one just says, what are your thoughts on the canary deployment model?
Yeah, absolutely. That's a great question. So canary deployments are used to test out, the impact of a new feature change on a limited audience, right? So because we don't want to roll it out to maybe the entire world of users, and we want to see how well that that feature sticks, or what's the usability of that feature is. So we deploy to a limited set of users, and then we monitor the feedback from the users, right, in that limited environment, to see how well they like it or not, right? Maybe even test for performance, test for usability, et cetera, so that once we are satisfied, with the quality of that release, we can either choose to release it to the broader audience or maybe roll back, right? So that's the whole idea. I personally like it. It's a great part of, shifting right. We talked about shift right, and we talked about canary testing as a key component of shift right.
Awesome. And then our next question just reads, how do we encourage developers to adopt either test-driven development or behavior-driven development?
Great question. And I think the answer lies in being able to communicate to them the outcomes, right? So the whole idea is the developers want fast feedback. They want to be able to do uninterrupted development. And what happens is that when developers build code, they often have to wait for testers to run the test and provide feedback, and that results in impedance, right? So the whole idea is to tell the developers, hey, can I work with you so I can build out the tests before you actually build any code, so that as soon as your code is ready, the tests are ready, right? There's no impedance, no waiting, right? So let's work together to understand what the behavior of the system is, document the behavior, understand the acceptance criteria, so that it's easy for you and me as a tester, so that I can get very fast feedback to you without any impedance and without any context switches. So that's sort of the way I would incentivize, is by looking at the outcomes that they can, or the benefits that they would get from it.
Awesome. Thank you so much for that, Shamim. So we are at the top of the hour and we need to close out, but I would like to remind our audience that this session was recorded. So maybe you joined us late, or maybe you had to leave us early. You should receive an email with a link to access this recording on demand, or you can find it living on the DevOps website at devops.com/webinars, and then just be sure to look in the on-demand section. At the top of the hour, I did promise we'd be giving away 4 $25 Amazon gift cards. Our winners are Ivana G, Alan W, Jill S, and Ravi B. So to our 4 winners, congratulations. Keep an eye on your email inbox to claim that gift card. But if you don't happen to see that email, do check your spam folder. I'd like to thank Broadcom Software for sponsoring today's program. And for everyone who joined us today, thank you so much for joining us. We appreciate you spending the last 62 minutes with us. And we want to just ask for one more moment for a survey that will pop up on your screen as soon as we close out. Otherwise, we do hope to see everyone at an upcoming Techstrong Learning program. Everyone, have a great rest of your day. And Shamim, thank you once more.
Thank you, Cody. Thank you, everybody.